quiet, but I figured better than nothing. So our sample surveys is our next unit. It is chapter 12, and I have given you a crossword puzzle as part of your homework, which you're going to be doing. And Zachary's pointed out that some of the definitions that are in the book are not identical to what you're going to see as the words. So you'll kind of need to, like two down, I think is one that you brought up, right? We'll look at two down. It's the exact definition in chapter 12 as random, and end up being random variable is the actual answer for two down. So just make sure that you realize that they're not going to match identically. They are made to go with our book, but they might not be word for word. So just kind of be careful there.
Yeah, it's going to go with 7 down.
7 down. So just kind of, you'll have to kind of fudge a little bit there. But for the most part, they're pretty straightforward definitions. You are going to have just a definition quiz, not next class, but the class after that. And what would that be for us? Tuesday, Monday? Yes. Monday. So plan on that. We are going to talk about and it's just going to be on all the different kinds of vocabulary that is associated with chapter 12, quite honestly, the survey vocabulary. And it's quite vocabulary intensive. So part of your homework is going to be to complete this thing here. And then I also want you to read chapter 12 and do the just checking. So you already know what your homework is ahead of time. But I'd like to kind of introduce chapter 12 before you read it so that you have kind of an idea and a framework for where to look at it. So if you guys would stop working on the crossword puzzle for just a second and just kind of hear me out on what I need to say before you read, okay? So chapter 12 talks about ways to collect data. And that's really where we are now. We're kind of done with the phase of analyzing our data. We did that with finding the mean, median, mode, the measures of center. We have graphed things. We have looked at bivariate data. We've looked at ways to display it, to describe it, to summarize it. Now we're just going to look at ways to actually do the method of collecting. And one of the things that we're going to be one way to collect data is by a survey. And actually, at the end of the year, you will have what we call a culminating project, which is in place of a final exam. Okay, because I really think that, quite frankly, after an AP exam and all the IB exams and everything else you guys are taking, y'all need a final too. Okay, so we're going to just kind of put what we've learned into action. And one of the things that is very popular is to conduct an actual survey. So we're going to talk about how to do that effectively and how it's not so effective. Because there are quite a lot of surveys that are conducted out in the world that are not very effective. Now, how many people get phone calls? It's election time now, right? Anyone get a phone call about, like, we want to know what you're going to vote for and blah, blah, blah time, right?
Damn.
Right. And so I just say, and click and hang up, right? So I am not going to tell you who I'm going to vote for. That's my opinion, and I don't feel like I want to share that with you. But it is key. They are trying to collect that data. So we're going to talk about how that data collection method, by calling your house, is probably what we call biased. There's some irregularities with it, and there are some issues with it. But there are obviously lots of ways to collect data. But before we get into the actual data collection methods, one of the things we need to talk about is the difference between a sample and a population. And we talked about this way at the beginning of class, or beginning of the year, actually, which you probably have forgotten. What is the difference between a sample and a population? Who can tell me? Give me what's the difference.
A population is everything that you're, like, anything that's included in what you're trying to collect for.
So in this example, this is a population. This is every NFL player in 2009 and what their salary was, right? A full population. Based on that, can someone tell me what a sample might be, Erica? A portion. So you guys come in every day and take a sample of 5, don't you? That is a sample size. Okay? So it is a sample of, or a portion of, the population. Now, when we think about surveying, okay, why might sampling be an effective method? Why might we want to sample a population? Why might we have to sample a population?
The population is too big to measure.
Sure. So, like, for example, finding out who people are going to vote for what's the big election in Virginia? It's Warner versus Faust, and then there's I don't know, there's a senatorial race, right? And then there's a local Because who's the local seat that's out? He retired. Frank Wolf, right? So Wolf left. Anyway, there's all these electoral elections. So we really probably couldn't ask. Let's go to the gubernatorial. Not gubernatorial, but I guess that's Maryland is gubernatorial, right?
Yeah.
Let's talk about Maryland for example. They could not possibly find a way to ask every registered voter who they're going to vote for and collect that answer, right? So they have to conduct a sample. How would they conduct that? And so that's what we're really going to be looking at. But looking at a sample, we're hoping can be the sample that we collect. We want it to mirror the population as much as possible. We want it to be reflective of what the larger population might actually say. Okay? So why do we do that? Why not survey everybody? Well, we just answered that question. Sometimes we just can't. Okay? Sometimes it's not possible. Sometimes it costs too much money. Might take too much time. There is one thing that the United States does every 10 years, okay, that we try to collect data on every single person. Would you agree in the United States? It's called a census. But what is a census? Where we try to collect data on the entire population. Okay? Is what the United States does, the U.S. Census Bureau, truly a census?
No.
Why not?
They don't send those home.
Okay, well actually they try, believe it or not, but there are certain facts of the population that are harder to count, okay? Homeless being one of them. Can you think of somebody else, another group or another subset of the population that might be harder to, illegal immigrants. They might be not willing to participate, right? So there are different, so it's not a true census and what the definition of a census is, but it's awful close, and we really try hard. We spend lots and lots of money to try to do that. Okay, well, we're going to specifically talk for a little bit about sample surveys, where we're looking at a specific sample. We know what a population is, we know what a sample is, and we know what a census is at this point, correct? Any confusion on those three words? Okay, good. So, what can go wrong when we sample? When they call Mrs. Mackert's house, when I'm eating dinner with my family who I haven't seen all day, and I really want to figure out what Connor Mackert did in 9th grade algebra 2 trig, and I need to know the answer to that question, Monica, and they're bothering me by calling me on my darn phone. Okay, what do you think I say? So do you think there's a bias, maybe a problem with my response to their survey? Sure, I have introduced a bias because I am not answering their question. I say, no thanks. Right? So that is a source of bias. And next class, we're not going to have time today, there's lots of sources of bias. That would be one of them. Okay? There's really, once you've collected your data already, you've collected your sample, there's really no way to fix a bias. That question specifically is going to come up on a future test or quiz, so I'm going to tell you that. Okay? If there is bias in a sample already, okay, if you collect a sample, and there's already bias there, there's no way to get rid of it. Okay? Matter of fact, what's one way you might think? Let's say I want to ask some people and I want to ask students what they think of Stonewall Jackson High School. Okay? And I ask you guys. Okay? Are you guys reflective of the population at Stonewall Jackson High School? I don't think so. You're all really smart kids, right? I'm not saying that everybody at Stonewall's not smart. I'm trying to be mean or anything. I'm just saying, like, you guys are probably a little, you're not as diverse as maybe everybody in the school. Would you agree? So we'd have to think about looking at AP stats classes. We'd have to maybe look at, an Algebra 1 Part 1 class, maybe like different levels, different grades maybe. There's no 9th graders here, right? They might have different opinions. So when we think about making our sample reflective, okay, if there's bias already there, some people think that I could take this little sample, we decided that we're not reflective, and if I just make it bigger, okay? Maybe I ask all the AP stats classes in Virginia or something, okay? Well, the bias is already there, isn't it? So if there's already bias and I just make my sample size larger, I'm just magnifying the bias. Okay? So that's kind of an important fact, and we'll talk more about that next class. But here is the best way to avoid bias in the beginning. Okay? We don't want bias to be there at all. We want our sample to be as clean and as reflective as possible, the best way to avoid bias is to talk about random sampling. Okay? So you can write it down, or you can print them off at home. I don't care. Okay? But random sampling, randomness, is the key number one element to preventing bias to begin with. Okay? And we are going to deliberately introduce randomness in our data collection methods. Okay? The number one type, we're not there yet, sorry. Randomizing and sample size. Sample size will also be important. You're going to obviously have to randomize. Why might sample size be important as well? It's not as reflective, maybe? Okay. So you have to make sure that your sample size is what we call large enough. We're not sure if it's going to be large enough to be reflective of our population. And that varies depending on your type of sampling. Okay. I'm going to come back to that in just a second. I'm going to look at something else. Okay. The number one type of sampling is called a simple random sample, SRS. Okay, and that I know it's going to be one of the definitions on your, I believe, on your, it should be on one of your classwork. But it's simple, and I will abbreviate it SRS all the time. Okay, just because simple random sample is really hard to write out. They mean the same thing. But a simple random sample has the following criteria. Okay, you do a simple random sample when you do NFL salads. Okay, I mix them up. I randomly pick one. That is a simple random sample, okay? Where I have everybody in the population here, and I just kind of mix them all up, and I pull one out, okay? And I got Rashard Mendenhall, the Pittsburgh Steelers. I don't know if he probably plays for them anymore or who he is, but randomly picked him. Fantastic, okay? Now, sample size matters, okay? We talked about that a second ago. In order for it to be an SRS, every possible sample of the size you plan to draw has an equally chance to be selected. What I mean is this. You come in and take a sample size of 5, right? We are not conducting a true SRS when we do that. Why not? Why mix them up every time? But that's a good thought. You have to mix them up. I agree with that. If you don't mix it, it's not an SRS. Well, let's just say the population of size 5 is all I cared about, the sample of size 5 is all I cared about. Still not an SRS. There's one little thing that's causing it from being one. Right. Okay. So because you're all taking 5 at the same time, okay, that really affects this criteria here, doesn't it? Okay. In other words, if Nathan takes his 5, goes back to his desk. When I come to take my 5 out, what is every person being, do they have a likely chance to be in my sample? Well, the 5 he has definitely won't be in mine, right? So it's not a true SRS. Okay, it's as close as we can get without taking, until May to get one little graph. Okay, so it's close, but not exactly. Each individual has an equally likely chance of being selected. That's really important. Each combination has an equally likely chance, kind of like we were just saying with the 5. We call it an SRS, and it really is the standard by which we measure all sampling methods. It is the best possible chance. So to be a true SRS, we'd have to do it one person at a time. Take your 5, find your average, put them back, mix them up. Next person, take their 5, write their average, put them back, mix them up. That would be a true SRS. Understand the difference? Yes, no, maybe so? Okay. So that is by which the number one sampling method that we're going to talk about. We'll talk about more next class, but truly understand what an SRS is. And then the last, we'll talk about other designs later. The last thing I want to talk about today, before I send you on your way to read chapter 12, not this, hang on, where did it go? There we go. A statistic versus a parameter. And this comes into play because a statistic is something that is based on a population. I'm a liar. I hate when I lie. A parameter is based on a population. statistic is based on a sample. And it is easier, PPSS, right? Okay. Sometimes we call it a population parameter. Sometimes we call it a sample statistic. In other words, if I think about the average that you're graphing every time up here. So let's say that this first dot here is 2.9 million. Okay, 2.9 million is that this dot, this smiley face here, is that a parameter or a statistic? It's a statistic because it's an average of a sample size 5, right? What would an example of a parameter be with our NFL salaries? The real average, the true average of all of the salaries combined. That would be a parameter. There is some notation that's involved here that we'll need to understand the difference. Okay? Sample mean, we know that, X bar. We've used that before, right? A parameter or a population mean uses the symbol Greek letter mu. And it looks like a U with a long tail on the left. It's called a mu, mu. Okay. The standard deviation, we know. We just use S for the sample standard deviation. Often we use S, the calculator is S with a little subbar X, is it not? Is that what we use for the standard deviation on our calculator? Okay, the population parameter for standard deviation is called a sigma. Now, I know that you guys know that this is a sigma 2 back from algebra 2, right? They're both called sigma. One's capital, one's lowercase. Okay, so this is also a sigma, but that means that's just the symbol for the population standard deviation. When we talk about proportions, which we're really not going to get into a whole lot until later, but they also have symbols. I'll go ahead and tell you what they are. Population proportion is just a P. That's kind of nice. And the sample proportion is something called a P hat. Okay? So these are okay to know the last two for symbols, but really need to know the difference between a population mean and a sample mean. So honestly, these are what's important. Okay? And we know that we've done that because we've calculated several sample means over and over the last couple of weeks anyway. Okay? All right, so next class we will talk about more sampling methods. We know one is an SRS, where you just put everything like in a hat or in a box, mix them all up and pull one out. There are other ways to conduct an SRS, and we'll talk about those next class. And then we will also talk about other types of sampling methods and the types of bias. You will read about those in Chapter 11, and those will help you define the vocabulary here in your crossword puzzle. Did I say 11? Sorry, yeah, Chapter 12. 11's one we just finished. So yes, Chapter 12. All right, any questions for me? All right, I'm not even sure I recorded any of that. I don't think I started the recording, which would be terrible. Yes, I did. Yay, you. Okay, you know your homework.